Hello everybody. So today we're talking about lesson 4.10, problem solving involving multiplication. We're on page 177 of the third grade textbook. And our strategy today is how can you use the strategy make a table to solve multiplication problems. All right, so unlock the problem today. Scott has a stamp album. Some pages have one stamp on them and other pages have two stamps on them. If Scott has 18 stamps, how many different ways could he put them in the album? Use the graphic organizer below to solve the problem. So what information do we know? We know that some pages are going to have one stamp. Other pages will have two stamps. And he has a total of 18 stamps. So how many different ways could he put them in the album? All right, so what do I need to find? How many different ways the stamps can be arranged? All right. What information do I need? I need to use that he has 18 stamps. Some of the pages will have one stamp on them, and other pages will have two stamps on them. How will you use the information? Well, we're practicing making a table, so I will make a table showing all the different ways of arranging the stamps. All right, so to make a table to show the number of pages with one stamp and two stamps, each row must equal 18. So when I combine my pages with two stamps and my pages with one stamp, the total has to be 18. So they started off by telling us he could have 8 pages with two stamps. So that's 16 stamps. So think of it as 8 times 2, 16. 7 times 2, 14. 6 times 2, 12. 5 times 2, 10. Okay, so if these pages have 8 pages with two stamps on them, there's a total of 16 stamps. The whole thing has to add up to 18. 16 plus what is 18? 2. So you'd have 2 pages with only one stamp. Here, if we have 7 pages with two stamps, there would be 14 stamps. 14 plus what is 18? 4. So you'd have 4 pages with just one stamp on them. If he had 6 pages with two stamps, he'd have 12 stamps, and he'd need 6 pages with one stamp to equal 18. If he had 5 pages with two stamps, that would be 10 stamps. 10 plus what is 18? He'd have to have 8 pages with one stamp. Okay, if we had 10 pages with one stamp, that leaves us 8 stamps. 8 divided by 2 would be 4. So 4 times 2 is 8, and 10 plus 8 is 18. 3 times 2 is 6. 6 plus 12 is 18. 2 times 2 is 4, and 4 plus 14 is 18. What if we had one page of 2? Whoops, sorry. I wrote that wrong. If we have one page of 2, 1 times 2 is 2. He'd have 2 pages, I have 2 stamps, and he'd have 16 pages with one stamp. So we should notice a pattern here. So we went with 8 pages, 7, 6, 5, 4, 3, 2, 1. We can't have 0 pages because it said he'll have some pages with one stamp, some pages with 2 stamps. Okay, so we won't have 0 pages of 1 or 0 pages of 2 at all. And then you'll notice here the pages with 1 go from 2, 4, 6, 8, 10, 12, 14, 16. So the pages with 1 are increasing by 2 each time the number of pages with 2 stamps decreases by 1. All right, so what number patterns do you see in the table? Well, the second column counts up by 2. First column decreases by 1. Okay. All right, 178. What if Scott bought 3 more stamps and now has 21 stamps? Some albums have pages with 1 stamp and some have pages with 2 stamps. Show how many different ways you could put the odd number of stamps in the album. All right, so buys 3 more stamps and now has 21 stamps. Some pages will still have 1 stamp. Some pages will still have 2 stamps. Show how many different ways he can put the odd number of stamps in the album. Okay, how many different ways the stamps can be arranged? What information do I need? 21 total stamps. Some pages have 1 stamp. Some pages have 2 stamps. How will I use the information? So again, remember we're practicing making a table. So we'll make a table. All right, I'm going to make a table to list all the combinations to make pages that total 21 stamps. Okay, so solve the problem. Let's look back at our example here. So our columns were pages with 2 stamps, pages with 1 stamp, total stamps. Okay, so let's use the same idea for this one. Okay, so we have pages with 2 stamps, pages with 1 stamp, and we have our total stamps. Well, we know our total stamps has to be 21. So our combination of these two would be 21. Let's start with the greatest number of pages with 2 stamps. So let's see. 10 times 2, 10 pages of 2, and I'd have 1 page of 1. 10 times 2 is 20. 20 plus 1 is 21. So we can keep track of that by saying 2 times 2 is 20. 9 times 2 is 18 stamps. 18 plus what is 21? 3. All right, let's try 8. 8 pages of 2 would give me 16 stamps. 16 plus what is 21? 5. Okay, I think I'm starting to notice a pattern here. 1, 3, 5. My next guess is that this is going to be 7. Let's see. 7 pages of 2 would be 14. 14 plus what is 21? 7. Okay, so we're starting to notice a pattern, right? These are decreasing by 1. These are increasing by 2. So let's just try this. 9, 11, 13, 15, 17, 19. And we can't have 21 because some of the pages have to have 2 stamps. Okay. So if I have 9 pages with 1, that leaves me 12 stamps. Well, 6 times 2 is 12. So that's good. 5 times 2 is 10, and 10 plus 11 is 21. We don't have to list these here. I'm just doing that to keep track of the product of the pages at times 2. All right. 4 pages of 2 would be 8, and 8 plus 13 is 21. 3 pages of 2 would be 6, and 6 plus 15 is 21. 2 pages of 2 would be 4, and 4 plus 17 is 21. 1 page of 2 is 2, and 2 plus 19 is 21. So how many different ways did we come up with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that makes sense, right? I went from 10 to 1, so 10. 10 different ways. What patterns do we see in the table? Well, the first column decreases by 1. The second column increases by 2. With odds starting from 1. How are these patterns different from the patterns in the table on page 177? All right, so here we're increasing by 2. Here we increase by 2. Oh, here the pages with 1 stamp are odd. Here, when he had an even number of stamps, the pages with 1 stamp were even. I just noticed I didn't put the answer to this one. There were 8 different ways, by the way. Okay, so on page 177, pages with 1 stamp are even. All pages with all the pages for the odd number of stamps I'm not sure I like the way I worded that. On page 177, the pages with 1 stamp are even, while the pages from the odd number of stamps is odd. While the pages with 1 stamp on page 178 are odd. Okay, that's a little more clear. While the pages with one stamp on page 178 are odd. Okay. All right, 179. Aaron's mother's making lemonade. For each picture, she uses 1 cup of lemon juice, 1 cup of sugar, 6 cups of water. What is the total number of cups of ingredients she will use to make 5 pitchers of lemonade? All right, so we need to know that she's got to use 1 cup of lemon juice, 1 cup of sugar, 6 cups of water. And we need to know the total amount of ingredients. So adding up all the numbers of lemon juice, the sugar, and the water. So make a table to show the number of cups of lemon juice, sugar, and water that are in one pitcher. Okay. Then we're going to multiply to find the number of cups of water needed for each pitcher of lemonade. So our top will be number of pitchers. We know that we're going to find 1 first, but we need to ultimately find the total for 5. So this blank here has to be a 4, right? Because we're making 5 pitchers. All right. So in 1 pitcher, I have 1 cup of lemon juice. So how many cups of lemon juice would I have in 2 pitchers? I have 2. In 3 pitchers, I'd have 3 cups of lemon juice, and 4 and 5. Okay. Cups of sugar. Well, in 1 pitcher, I have 1 cup of sugar. In 2 pitchers, I have 2 cups of sugar. 3 pitchers will have 3, 4, 5. All right, but now this one, there's 6 in every pitcher. So 2 times 6 is 12. 3 times 6, 3 times 6, all we have to do is add 6 to the 12. 12 plus 6 is 18. 18 plus 6 is 24. 4 times 6 is 24. 6 sets of 5 or 5 sets of 6? We're doing 5 pitchers of 6, but we can read it as 6 times 5, right? And 6 fives is 30. All right. Then, for the total number of cups of ingredients, they added all of the cups for 1 pitcher. So if there's 8 in every in every pitcher, there's 8 cups of ingredients. Shouldn't this increase by 8 each time? Well, let's just see. 12, 13, 14, 15, 16. Yep, 8 plus 8 is 16. I'm going to assume that this one's going to be 24. 18, 21, 24. 24 plus 8 is 32. Let's see. 24, 28, 29, 30, 31, 32. And this last one's probably going to be 40. 30, 35, 40. Okay, so in 5 pitchers of lemonade, there are blank cups of lemon juice. In 5 pitchers of lemonade, there are 5 cups of lemon juice, 5 cups of sugar, 30 cups of water, which makes a total of 40 cups of ingredients. Well, what if it takes 4 lemons to make 1 cup of lemon juice? How many lemons would it take to make 20 pitchers? Okay, so we still have 5 pitchers, but instead of 1 cup, it's going to take 4 lemons. Oh, for every 1 cup of lemon juice, it's going to take me 4 lemons. So 4, 8, 12, 16, 20. It'll take me 20 lemons to make 5 pitchers of lemonade. So explain how you can use the table to help you find the answer. Okay, so 1 times 4 would be 4. 2 times 4 would be 8. 3 times 4 equals 12. 4 times 4 equals 16. 4 times 5 equals 20. Okay. So each column for lemons would increase by 4. What patterns do you see in the total number of cups of ingredients? Well, remember when we got to here, we said, okay, so if there was one pitcher with 8 total cups, it would have to increase by 8. Each pitcher increases by 8 total cups. All right, number 4. Julie saw 3 eagles each day she went bird watching. How many eagles did she see in 6 days? All right, so we can make a table for this. We'd have days and eagles seen. In one day, she saw 3 eagles. How many did she see in 6 days? Okay, well, after 2 days, she would have seen 6. After 3 days, she would have seen 9. After 4 days, she would have seen 12. After 5 days, she would have seen 15. What are we doing? We're just counting by 3, right? We're adding 3 to the previous day. 6 days, 18. So she would have seen 18 eagles in 6 days. 3 times 6 is 18. Greg has $1, quarters, and dimes. How many ways can you make $1.75? So $1, quarters, and dimes. Total. All right, so he has to come up with $1.75. Okay, so how many different ways can he do that? Our columns are dollars, quarters, dimes, and then his total. Well, let's start with $1. Okay, if he has $1, he still needs 75 cents. I can't get 75 cents with just dimes. I can get 75 cents with just quarters, right? I could have 3 quarters and 0 dimes. All right. I could have $1 and I could have 1 quarter. That's $1.25. Okay, $1 and a quarter is $1.25. And I need 50 more cents to get to $1.75. Well, a dime is worth 10 cents, right? So I could have 5 dimes. That would be $1.75. All right. Now, are those the only ways I can make $1.75 using dollars? Yeah, I can't do 2 quarters. 2 quarters would be 50 cents, and there's no way to get another 25 cents using just dimes. I would have to have some nickels. Okay, so let's switch to $0. And how many quarters are in a dollar? 7, right? So we could have 7 quarters. All we did was trade the $1 for 4 more quarters, and 4 plus 3 would be 7 quarters. All right, so that's $1.75 as well. Again, no dollars. Is there a way of making $1 with just dimes? Yeah, 10 dimes, right? That also is $1.75. So what I've done is I've rewritten this first one 2 different ways. I've used just quarters, and I've used quarters and dimes to replace the dollar. Now, is there a way of taking this dollar, the 1/4, and the 5 dimes and writing it differently? Yeah, I can still replace the dollar with 4/4. So I could have 5/4. These two would be equal to 5/4 because there's 4/4 in a dollar. 4 plus 1 is 5. And I would still have the 5 dimes. So that is $1.75. Okay. What if we had no dollars, 1/4? How could we get a dollar? Remember, if we had the 5 dimes, is there a way of making a dollar out of just dimes? Yes. 10 dimes would be a dollar. 10 plus 5 is 15. So 15 dimes is $1.50 plus another quarter is $1.75. Okay, so there are 6 ways. We could have, let's see, list the ways or name the ways. $1, 3/4, $1, 1/4, 5 dimes, 7/4, 7/4, 3/4, 10 dimes, 5/4, 5 dimes, 1/4, 15 dimes. All right, number 6. Cami needs 36 postcards. She buys 4 packages of 10 postcards. How many postcards will Cami have left over? Okay, so we don't need a table for this one. We know that she needs 36 postcards. She buys 4 packages of 10. What is 4 packages of 10? So if we wanted to represent that, we could draw 4 circles and we'd have 10 cards in every package. 10, 20, 30, 40. So she bought 40 postcards. She needs 36. How many postcards will she have left over? Well, 40 take away 36. I can't take 6 for nothing, so I'll regroup the 4 tens as 3 tens and 10 ones. 10 ones take away 6 ones is 4. 3 tens take away 3 tens is 0, so 4. She would have 4 postcards left over. So if we had to explain, 4 packages of 10 equals 40. Then subtract the 36 she needs. All right, so the explanation, 4 packages of 10 is 40. Then subtract the 36 she needs to get what is left over. 40 take away 36 is 4. Philip has 8 books on each of 3 bookshelves. His aunt gives him 3 new books. How many books does Philip have now? Well, okay, so let's say bookshelves and books. So with 1 bookshelf, he has 8 books. 2 bookshelves would be 2 times 8, 16 books. 3 bookshelves, 8 plus 16 is 24. 3 times 8 is 24. His aunt gave him 3 new books. So 24 books that he has, plus 3, he has 27 books. Stuart has 2-ounce, 3-ounce, and 4-ounce weights. How many different ways can Stuart combine the weights to make a total of 12 ounces? List the ways. Well, okay, so 2-ounce, 3-ounce, 4-ounce, and the total has to be 12. All right, so an obvious one to me would be 6 times 2. So 6 2-ounces, 0 3, 0 4s would give me 12 ounces. All right. How about 5 2-ounces? 5 times 2 is 10. There's no other way of getting, I can't add 1 3-ounce. That would be 13. So I can't have 5. Let's try 4. Can I have 4 2-ounces? That would be 8, and I would need 4 more. 4 times 2 is 8. 8 minus 8 taken from 12 is 4. Okay, well, that makes sense. I could have 1 4-ounce weight. All right, so that's 12. 3. 3 times 2 is 6. We could do 3 2-ounce weights. That would be 6. And I'd have to have 6 more ounces. Well, I could get that with 2 3-ounce weights. Okay, so 3 times 2 is 6. 2 times 3 is 6. 6 plus 6 is 12. All right. Can I have 2 2-ounce weights? 2 2-ounce weights would be 4 ounces, and I would need to have 8 more ounces. I can do that. 2 times 2 is 4. I need 8 more ounces. Well, 2 sets of 4 ounces is 8. So 2 4s is 8. 2 2s is 4. 8 and 4 is 12. Okay, can we have 1 2-ounce? Yeah, I believe we can. 1 2-ounce would leave me 10 more. Well, if I have 2 3-ounces, that'd be 6, 7, 8. I would need 1 4-ounce. So that's all the possibilities with 2 ounces. Can I have just 3-ounce weights? Yeah. 4. 4 times 3 is 12. All right. Can I have less than 4 ounces? Less than 4 3-ounces. 3 times 3 is 9. There's not going to be any way to get 3 more from a 2-ounce and a 4-ounce. So that's it for the 3 ounces, because we've also already got the marks of 2. How about 1 with 3? If I had 1 3-ounce weight, I would still need 9 more. There's no way to make 9 out of 4 and 2. Okay, how about just sets of 4? Yeah, 4 times 3. So our last one would be 0 0 3. So 1 2 3 4 5 6 7. So this bottom one is 0 2-ounces, 0 3-ounces, and 3 4-ounces. So 7 ways. So 6 2-ounce weights, 4 2-ounce plus 1 4-ounce weight, 3 2-ounce weights plus 2 3-ounce weights. 2 2-ounce weights plus 2 4-ounce weights 1 2-ounce weight plus 2 3-ounce weights plus 1 4-ounce weight. And then we had 4 3-ounce weights, and we had 3 4-ounce weights. Okay, boys and girls, that's it for Chapter 4. The next time we meet, we'll be reviewing for the Chapter 4 test. So until then, may the numbers always be in your favor.